In this video, we'll take a look at our first case where we're dealing with a hypothesis test for means with two independent samples. So here, our case 1 is the value of sigma 1 and sigma 2 is unknown, and we do not assume it to be equal. So we have notation that we should parallel notation that we've had before. Subscripts of 1 will indicate that they're coming from population 1. And subscripts of 2 will indicate that they're coming from population 2. And so we have population means and sample size and sample standard deviation. Here the test statistic is going to be a t-statistic. And so that t-statistic here is going to be calculated in this way. The degrees of freedom, it is going to be either 1 less than n1 or it is 1 less than n2, whichever of those two values is smaller. And that's something that will be easy to overlook when we start using StatDisk, but that is an important observation when we make these calculations. So we can see those degrees of freedom. It's chosen a little bit differently than what we did in the previous chapters, where we always took 1 less than the sample size. It is the more restrictive of the two, so the smaller of those two values. The confidence interval, again, is shown here, and that margin of error, how that is calculated, is shown here, and it's using the same degrees of freedom from above. So using StatDisk for this first case, and in fact all 3 cases that we go through here are going to be the same in terms of what we choose. We're going to choose the mean with 2 independent samples. The only thing that's going to be different are those values that we input. The values that we know are going to be subtly different. And then based on what we plug in, the values that come out will also then be subtly different. So we're going to get t-values out of here for our critical values for the test statistic. The p-value will be output and the confidence interval will be output. So let's look at an example. A study was conducted on arrival delays for 2 different recurring flights. Below are the summary statistics. Right, so we know that for flight 1, there were 12 flights. The average delay, the mean delay was negative 20.5 minutes. Standard deviation 12.38 minutes. For flight 2, there were also 12 flights. The mean delay was negative 15.08 minutes and a standard deviation of 15.62 minutes. We want to use a 0.05 significance level to test the claim that, what is the claim we are testing? Test the claim that Flight 1 and Flight 2 have the same mean arrival delay. So let's write symbolically the claim. It is a claim about the mean. It's the mean for 2 different values, and the claim is they have the same mean. If that is the claim, we then identify the opposite, which is they're not actually equal. I don't know which one is bigger, but I don't really care. I just care that they're not the same. Then our null hypothesis and alternative hypothesis. For this particular problem, they match up exactly with the claim and the alternative. The null hypothesis does not always show up as the claim or as the counterclaim. The alternative hypothesis is always one of them. It is always the one that does not allow the 2 sides to be equal. All right, so we are going to go to StatDisk and we are going to input our values here. So this I will use as up here. These will be population 1, since it was presented first. and then here population 2. All right, so let's go over to StatDisk. We're going to choose analysis. We are dealing with a hypothesis test. This hypothesis test is dealing with a mean, and we have more than one sample, so it's either two independent samples or matched pairs. And so we need to identify, is this independent? So is there a natural pairing of these two things? So both of our samples had 12 items, but there's nothing that suggested a natural pairing of one item in the first sample with one specific item in the second. So we are dealing with independent samples here, even though they have the same number in their sample sizes. We will input the alternative hypothesis, which is that those two values are not equal. Our significance level is 0.05. Our first sample size was 12. Our first sample mean and first sample standard deviation, they were negative 20.5 and 12.38. Negative 20.5 and 12.38. I would make the quick observation here. The standard deviation that we were given, it said S, so that is a sample standard deviation. If it was sigma instead, that is a population standard deviation, and it would go down in the next spot. The second sample, it also had a sample size of 12, and we'll go back and look at what the mean and standard deviations were there. So for the second one, the mean was negative 15.08 and 15.62. Negative 15.08 and 15.62. And that is what we'll do. We'll evaluate it. And we get a p-value of 0.3569. So our p-value is 0.3569. We compare that p-value to the significance level, which was 0.05. If the p-value is high, then the null will fly, so we fail to reject the null. This says also identify the associated confidence interval. So that confidence interval that we were given, that's calculated here in StatDisk, is a 95% confidence interval. It is negative 17.388 to 6.548. And here we notice that 0 is between this value and this value. So this is a reasonable belief. And when I write it that way, and when I say that, I'm not saying that we have evidence of it, that it's for sure true. What I mean is we don't have evidence that it's not true. It is possible. It is living in that confidence interval. So that is just as possible as any of these other values. And so a difference of 6 is also possible. If it was a difference of 6, then mean 1 would be larger. A difference of negative 17 is also possible, in which case mean 2 would be larger. So we can't say that mean 1 is equal to mean 2, but since 0 is in that confidence interval, it's reasonable to believe that, but it's reasonable to believe the others as well. We don't have evidence of any of the alternatives. All right, we will talk to you later.